velocity slash acceleration. Acceleration has 2 C's, I believe. 2 C's. I know that because the first time I taught calculus, I misspelled it, and someone yelled at me. There's a woman in the front row. ACC! Oh, acceleration. She was like 80 years old. I remember her face. Yeah. ACC! Oh my god! Yeah. She got it. Oh yeah. Hey, what's up? It's hot in here, right? Yeah. Sweating it out. Should have a pool party. Okay, so let's. This sounds fun. But S of t. This is going to be the position at time t. So it's the position of an object at time t. So S is always our position function. This is always given in the problem. They'll always give you the position function in all the problems. And so first there's a formula that's really important for the homework. You probably will not see this on your test. It's the average velocity. The average velocity over AB is, so if it was your function f, the average rate of change, you would just use the formula. You would do f of b minus f of a over b minus a. So here it's s, so you just use this. So when the homework asks for the average velocity, you just use this one, okay? So you do s of b minus s of a over b minus a. We'll do one later today, we'll do one. One semester, one time I put it on a test, because I was trying to be nice. I thought, oh, it's easy, and it was a disaster. Like, it didn't go well at all, because I never do it in class, right? So it makes sense that people would get it wrong. So we'll do one today, just so you see how to do the homework. So that's the average velocity. If you take the limit of that, you're going to get the instantaneous rate of change. So you'll get the velocity, the instantaneous velocity. Okay? So let's go ahead and write all that down. So the velocity is the derivative of position. So the velocity will be s prime of t. That's the velocity function. So if you have position, the first derivative is velocity, right? The first derivative is velocity. So let me just recap here. Position is s of t. I'll write it above so you have it all in one place. I'm going to write all of them in one place so you have them. So position, velocity. Hopefully that makes sense, right? If something gives you your position, the rate of change of position is velocity. You can think of think of I-4 when you're driving, right? The speed limit's always miles per hour, so it's like the change in miles over the change in hours. Right? Just thinking of I-4 because I drove there today. It's really dangerous. So change in miles. Do you all drive on I-4?
No.
Yeah. Isn't it horrible? Yeah, I do 80 and people like honk at me. And, I started listening to like really peaceful music. like really chill stuff. Changing miles over change, so that's like miles per hour, right? This tells you the position, right? This is the change in miles, and this is the time, change in hours. So. Okay, so velocity is the change in position over time. What if you change your velocity over time? What would that be? What's the change in velocity? Something you were going to say. Acceleration. That's how fast you're speeding up or slowing down, right? So acceleration is s double prime of t. Okay, so s double prime of t. So the first derivative is velocity. The second derivative is acceleration. Right? Second derivative is acceleration. And you can think of this as v of t. If you want, v for velocity. We can make up names, and we can call this a of t. In physics, they tend to use a lot of formulas. I was recently looking at a physics book a few weekends ago for fun. Long story. And they had all kinds of crazy formulas in the book. I was like, whoa, this is way more complicated than what we do in this class. This seems easier to me, because you just take derivatives to get the rest of the stuff. Right? So they give you this. The first derivative is velocity. The second one is acceleration. Ooh, this is important. Speed is different. See, velocity has a direction. Like if you're going that way, that might be positive, and then going the other way would be negative. So velocity has a direction. Speed does not. Speed is the absolute value of velocity. That comes up in Calc 2. I haven't taught Calc 2 in a while, but I remember the first section has like this velocity problem. And like there's a plane flying this way. They give the speed of the plane, but like the velocity is negative, so you gotta like, think. So speed is the absolute value of velocity. And this one's just for fun. You're not going to see this one. The third derivative, this is called jerk, I believe. Jerk. Like, don't be a jerk. Jerk. And I don't know, I forgot to Google it. The fourth.
It is.
It is?
Yeah.
So what are they called? The fourth, fifth, and sixth?
Snap, crackle, pop.
Snap, crackle, pop.
And
Yeah.
then the 7 and 8 is like lock and
Pop and
some-
lock.
Pop and lock.
Yep. Wow. Some major nerdage. That's good. Like, yeah. I think of the people who like make rockets. Those are the people who use this stuff, right? I mean, I'm guessing, right? So like rocket science. And people say, well, it's not rocket science. No, it actually is. Like, yeah, those are the people who work, I guess, with this stuff, like jerk and stuff like that. So snap, crackle, pop will be the fourth, fifth, and sixth derivative. We won't even see jerk in this class. It's not even going to come up. So don't worry about jerk. There's a formula that will be given to you, but you kind of have to know what it is a little bit. Rather, the form will be given. The position of a free-falling object. So if something is falling, like if you drop a penny from a building, of a free-falling object. Okay, so if you drop like something from a building, neglecting air resistance. So there's no air resistance. So neglecting, I'll write it down for correctness. Neglecting air resistance. Resistance is, and there's a formula, it's S of t equals 1/2 g, g is the acceleration due to gravity, t squared plus s naught, v naught t plus s naught. Okay, what'd you say, naught? Naught? That's v naught. V sub 0 is written v naught. Naught is spelled N-A-U-G-H-T. I Googled it. It means zero in English, but what? Like, who says that? I had not burgers for breakfast. Like, I had 0 burgers. Who said that? How many slices of pizza did you have? Not. Apparently it means 0, but maybe only in physics. So physicists love to say v naught, s naught. It's v sub 0, s sub 0. When you're lazy, you'll say v 0. You forget to say the sub, because you can only say so many words. So basically, you'll read the question, and you have to plug these numbers in. They'll give you this in the problem. Okay. Yeah. What else? G is the acceleration due to gravity. ACC due to gravity. Anyone know what that is?
9.81 meters per second.
Oh, there's a 1? Oh, I didn't know that. Okay. Is it? Well, I'll put 8, but I believe you.
9.8132, I think, is like the first 5.
Whoa, so hardcore! Yeah, cool. Yeah, I guess you knew physics. That's the acceleration due to gravity. So gravity is pulling us down now, right? I guess that's why we're not floating, unfortunately, or fortunately. Or if you use the other units, it's negative 32 feet per second squared. That's the other. What are those called? These units, English units or something? Empirical. And these are SI, right? SI units, empirical. Yeah. Our calculus book tends to use a lot of these. Yeah. They use stuff like inch pounds when they talk about force. Physics people hate that stuff. It's fun to like tease physics people about it. And then S sub 0, this is your initial position. This is really important. So initial position. And V sub 0, this would be your initial velocity. Yes, good. Like initial velocity. Initial velocity. All right. Good stuff. And you don't have to memorize this. It says it in my notes. It says don't have to memorize. Apparently I wrote it there in a red pen. So you don't have to memorize this. You just have to know S0 and V0. Okay. S0 is initial position. V0 is initial velocity.